Today we're going to be looking at solving equations by substitution. Solve the system of equations. They give us two equations, 4x plus 2y equals 8 and y equals x minus 2. So we're going to take the second equation, y equals x minus 2, and substitute it in for the y in the first equation, and we do that down here. But before we go ahead and do that, I'd like to just read this note. Remember to solve for both the x and the y variables. It's so easy when you're solving for one to forget to solve for the other one. But getting back to the problem, we said we were going to substitute that x minus 2 in for y, and we did that right here. The second step shows where we distributed the 2 to the x as well as the 2 times the minus 2. And we get 4x plus 2x minus 4 equals 8. Remember that positive 2 times a negative 2 gives us a negative 4. Combining like terms, we take the 4x plus the 2x, and that's where we ended up with our 6x. We still have r minus 4 equals 8. Adding 4 to both sides, we end up with 6x equals 12, but we do not want 6x. So we divide both sides by 6, and we find that x equals 2. Substituting that x equals 2 into our second equation, y equals x minus 2, now that we know x is 2, we put that in the equation, and we find that y equals 2 minus 2, or 0. So the point 2, 0, is a solution to this system of equations. Keeping on and solving for a system of equations, we're given another set of equations, the x plus 2y equals 8 and x equals 6y. Since we know x equals 6y, we substitute that in the first one. And when we do that down here, we have 6y plus 2y equals 8. Combining like terms, we find 8y equals 8, but we don't want 8y, we want 1y. So we divide both sides by 8, and we find that y equals 1. Substituting that in, x equals 6y, well, now we know our y is 1. So when we substitute that in, we find that x equals 6. So now we know the point 6, 1 is a solution to this set of equations. Solving the next system of equations, we have negative 4y minus 8x equals 16, and 2y plus x equals 10. So the easiest way to do this is to take the 2y over to the other side by subtracting the 2y on the second equation, and you find x equals 10 minus 2y. Now that we've isolated the x, got him all by himself, we can easily substitute this in the first equation for x. And when we do that, we get a negative 4y minus 8 times the quantity 10 minus 2y equals 16. Again, we're going to distribute that negative 8 to 10, and that's how we got our negative 80. And our negative 8 to a negative 2, and that's how we got our positive 16. Remember, again, a negative times a negative will be a positive. Combining like terms, we have a negative 4y plus 16y. We find that that's 12y. We still have our minus 80 equals 16. Adding 80 to both sides, we find that 12y equals 96, but we don't want 12y, we just want y. So we divide both sides by 12, and we find that y equals 8. Solving now for x, we use the equation x equals 10 minus 2y. Now that we know y is 8, we have 10 minus 2 times 8, which ends up being a negative 16, and our x is a negative 6. So the point negative 6, 8, is a solution to this system of equations. Continuing on, we're given another system of equations, y equals 5x plus 2, and 10x plus 4 equals 2y. Substituting the first equation into the second one, we have 10x plus 4 equals 2 times the quantity 5x plus 2. We distribute that 2 to the 5x and we find that that's 10x. And distribute the 2 to the positive 2 and we find that that's plus 4. Now we have 10x plus 4 equals 10x plus 4. Well, that's true and the equations are equal, so there are an infinite number of solutions to this system of equations. Solve the system of equations. We're given another set of equations, y equals 3x minus 4, y equals 3x plus 9. Since the two equations are both equal to y, we can set them equal to each other. So we have 3x minus 4 equals 3x plus 9. Subtracting 3x to both sides, we find negative 4 equals 9, which is not true. And anytime you get a statement like that that is not true, there are no solutions to this system of equations.